Right, children. Assignment number 4 of alcohols, phenols, and ethers. For nomenclature, there's only one example to be explained. CHC, C2H5. I'll expand C2H5 like this. Then CHCH3, CH2OH. This is the longer chain and direction of counting. You can see this is a straight chain of 5 carbon atoms, methyl at carbon number 2 and 3. So IUPAC name is 2,3-dimethyl 1-pentanol. I'll repeat, 2,3-dimethyl 1-pentanol, and this is a primary alcohol. Now coming to fill in the blanks. Almost towards the end, we are given 3-methyl 3-pentanol. I'm drawing a structure for that. This is 3-methyl 3-pentanol given. When this is heated with copper, it will undergo dehydration. So answer D will be first sequence. This is answer D. And this alcohol is prepared by the reaction between C and ethyl Grignard. It means 2 carbon atoms in this alcohol, these 2 will come from Grignard. Remaining part will come from carbonyl compound. So this part comes from 2-butanone. C is 2-butanone. Butanone is obtained by the reaction of B with aqueous NaOH. It means B is a geminal dihalide. And this halogen may be whatever is the halogen given on the arrow. And A reacts with HX excess to give 2,2-dihalo. There are 2 answers possible for A. A may be 1-butyne or 2-butyne. For A, both the answers are correct. Coming to second sequence. Propene with sulfuric acid hydrolysis gives 2-propanol according to Markovnikov rule. Next reaction is sulfuric 443 Kelvin. This is dehydration, will give an alkene, that is propene. HBr peroxide anti-Markovnikov addition will give 1-bromopropane. Aqueous KOH. NSR takes place to give 1-propanol. Then acetic anhydride will give 2 products. I'll write here, acetic anhydride is this is acetic anhydride. When this alcohol reacts with acetic anhydride, this hydrogen combines with this part to give acetic acid. This carbon will form a bond with this oxygen atom. This is esterification. So one product will be ester, and the structure of ester will be, this is the ester formed, and the second product will be acetic acid, CHCCOH. Coming to third sequence. In third sequence, no hint is given anywhere in the entire sequence. But on the basis of reaction conditions, somewhere in the middle, you can see preparation of phenol on the by using cumene. That method is involved. Moreover, in the last reaction, we are using sodium dichromate sulfuric acid. That oxidizing agent is chromic acid, and that is used only for the oxidation of phenol. So last answer F will be benzophenone. This is F. E is phenol. And this E is obtained by the reaction of D with dilute sulfuric acid. It means this is cumene hydroperoxide. This is cumene hydroperoxide, that is D. This is obtained by the reaction of C with oxygen. It means C is cumene. Cumene is obtained by the reaction of B with benzene. This is a special Friedel-Crafts alkylation reaction. So this reactant is propene. So propene with benzene in the presence of phosphoric acid generates cumene. And this propene is obtained by the reaction of A with alcoholic KOH. Now, in this case also, there are two answers possible for A. It may be 1 halopropane or 2 halopropane. So these are the answers: A, B, C, D, E, F. These are the answers for third sequence. Coming to fourth sequence. 2-pentanol, this is dehydration, gives pent-2-ene. This is according to Sirzoff rule. Next reaction is hydration. This is addition of water according to Markovnikov rule. Product will be 3-pentanol. 3-pentanol with PCl5 will give chloro product, T-chloropentane. 3-chloro with aqueous KOH gives 3-pentanol. 3-pentanol with ethyl grignard. Now, this will lead to the formation of alkane, which corresponds to the alkyl chain of Grignard reagent, that is ethane. And the second product is alkoxy magnesium halide. This product will be, bond will be formed through this oxygen. This is 3-pentoxy magnesium bromide. I'll repeat, 3-pentoxy magnesium halide is the byproduct. Last sequence. Again, towards the end, we are given ethyl propanoate. In this ethyl propanoate, if you write the structure, ethyl chain is attached to oxygen atom, which comes from alcohol. Propyl propanoic acid, that part comes from carboxylic acid. So above the arrow, we are given F, E and F react in the presence of sulfuric acid. It means out of E and F, one product is ethanol, the other product is propanoic acid. But if you further go back, E is obtained by the oxidation. Alcohol is not obtained by oxidation. Carboxylic acid can be prepared by oxidation, right? So E will be propanoic acid. I'm writing now. E is propanoic acid. F is ethanol. And last reaction is reduction of ethanol. This will lead to the formation of two alcohols. One is propanol and the other is ethanol. Now we go back. This propanoic acid is obtained by the oxidation. And if we further go back, D is obtained by oxidation. I'll repeat. E is obtained by oxidation of D, and D is also obtained by oxidation of C. It means this carboxylic acid is obtained by oxidation in two steps. If you think of oxidation of primary alcohols, primary alcohol on oxidation gives aldehyde. Aldehyde on further oxidation gives carboxylic acid. So this is obtained by the oxidation of aldehyde. Aldehyde is obtained by the oxidation of alcohol. And this alcohol is obtained by the reduction. This reduction may be carboxylic acid or aldehyde. B may be propanol or propanoic acid, because reduction of both will give propanol. If B is aldehyde, then A is 1,1-dihalopropane. And if B is propanoic acid, then A is 1,1,1-trihalopropane. So if A is this, B is this. Second option, if A is this, B is this. After that, there's only one option for remaining answers. Explain why, you'll find in notes. In case you have any difficulty, you can always call me. Coming to next, what happens when? I'll verbally explain. 2-butanol what happens when 2-butanol is heated with concentrated sulfuric acid at 443 Kelvin? Uh, it will undergo dehydration to give 2-butene according to Sizerf rule. So main 2 points are dehydration and Sizerf rule. Product is 2-butene. You have to write balance equation. Next, vapors of 2-methyl-2-butanol are passed over hot copper. It undergoes dehydration to give an alkene according to Sizerf rule. I'll write the product. This is 2-methyl-2-butanol. So this will be the alkene formed. 2-methyl-butene will be obtained. Next, phenol is warmed with chloroform and aqueous NaOH, and product is hydrolyzed. This reaction is what you call Riemann-Tiemann reaction. So you'll write the balance equation and say that Riemann-Tiemann reaction takes place to give salicylaldehyde, right? Salicylaldehyde. Coming to conversions, acetylene into ethyl alcohol. There are different methods to convert acetylene into ethyl alcohol. We can use HX in excess. According to Markovnikov, this will give 1,1-dihaloethane. React with aqueous NaOH. I'm not writing the reagent. You should be aware. This will give ethanol. Then reduction, LiLH4, will lead to formation of alcohol. Chlorobenzene into toluene. I'm not even writing on the board. This you can carry out in one step by Wurtz-Fittig reaction. Wurtz-Fittig reaction. So react the given compound chlorobenzene with chloromethane in the presence of anhydrous aluminum chloride. Sorry, in the presence of zinc. Sodium diether. Wurtz reaction, Wurtz-Fittig reaction. Next, normal propyl alcohol into normal butyl alcohol. We have to prepare a primary alcohol which contains 1 carbon more than the starting metal. So last reaction will be between propyl grignard and formaldehyde. Of course, hydrolysis is required. You have to convert this into Grignard reagent. Convert alcohol into alkyl halide. Then react with magnesium diether, you will get Grignard. React Grignard with HCHO, you will get final product. Aniline into benzoic acid. Aniline into benzoic acid. You can convert aniline into diazonium salt. You studied in alkyl aryl halides. Convert diazonium salt into phenol. Simple. React with water. Wait a minute. Heat with water. This will give phenol. Now you perform Riemann-Tiemann reaction using CCl4, or you can perform Cobb's synthesis, and this will lead to the formation of salicylic acid. But you have to write all proper reaction conditions. Let us say I use Cobb's synthesis, then it will be CO2, aqueous NaOH, 400 Kelvin, 4 to 7 atm pressure. This is one set of conditions, and this is followed by hydrolysis. Last reaction, heat with zinc dust, phenolic group will be removed, and you'll get benzoic acid. Next conversion, ethyl alcohol into tertiary butyl alcohol. Hot copper Oxidation will give ethanol. React with methyl grignard. This will give 2-propanol. Now repeat both the reactions. Again, hot copper will give ketone. Then again, methyl grignard, you'll get final product. Right? So you have to repeat these reactions, get final product. Next, propanol into 1-butanol. It's propanol into 1-butanol. Yes. Reduction will give alcohol. Convert alcohol into alkyl halide. Alkyl halide into Grignard reagent. Last step, react with formaldehyde. You'll get the final product. Last question. Give IUPAC name of the phenol. If I say the phenol, it means phenolic group is present. Look here, try to understand. So far, formula is C6H6O. But the formula of phenol given is C7H8O. C7H8O. If I subtract this, 1 carbon and 2 hydrogen atoms are left. I have to fit in 1 carbon and 2 hydrogen atoms more into this structure. These 5 corners have 1 hydrogen each. If I remove 1 hydrogen from any one of these corners and combine with this, it becomes methyl group, right? So I have to attach a methyl group, but at which corner? At ortho, meta, or para, which position? Now, further the question says, this readily gives white precipitates of C7H5OBr3 when treated with bromine water. Now, in the formula of product Br3, 3 bromine atoms are present. It means reaction of this compound, whatever it is, with bromine water will lead to tri-substitution. Means there will be replacement of hydrogen from ortho, and para position by 3 bromine atoms. It means methyl group cannot be present at ortho and para, can be present only at meta position. So the answer is 3-methylphenol. 3-methylphenol is the answer, right?